50/50. And we need to add this main panel. I'm just gonna say add new main panel. I know, we're not making a singleton. Yeah, I'm aware. It's okay. Let's get rid of some of our imports. And then we need to set the properties of this. So we'll make a constructor. We will say set background to be color white. And then we want to set the size of this. Set preferred size, new dimension, 900 by 600. I really do like this resolution for games. It's just a very small window that'll fit on almost all monitors, and for the pixel sizes of the resolution for the panel and stuff, you know, most games will run at a pretty high frame rate with this resolution, is basically what I'm saying. So let's give this a shot. It appears to be working. We drew our square on a white background. The canvas is the right size. Okay. So we can do a similar thing to what we did before. We can say image icon. Icon is a new image icon. And we can give it the location of our Funachan PNG, and then instead of filling a rect, what if we did draw image? And this follows a very similar layout to what we did in JavaScript. We're gonna say the image name. We're going to say the location of the image, X and Y, and then we're going to do the width and height of the image. But there's one more thing that draw image takes. It's called an image observer. What is that? That's a good question. We're going to say null. Let's look at this. Graphics is not available. So it wants it to be an image instead of an image icon. So let's see if we can get there. We're going to say image instead of image icon. And then let's say new image instead of image icon. See if we can get this situated. I believe we can say new buffered image, and we do not have a way to load it as a buffered image. So let's see if there's a different way we can load this, right? Let's try the image. Image. Let's look at these. Image. There is a image library that we can use that's already in Java. It might be part of Toolkit. No. Let's look at load image. File Java. Okay, image.io is the library that I'm thinking of. So we're going to say image.io.read. Is that correct? Yes. And that will be a file that it is reading. And then this is mad. Says string is not possible because it needs to be a file. So we will say new file. A file in Java is basically just a location. It's not actually a file, it's just a path to a file. And this is still underlined because we want this to be a buffered image. And a buffered image is really similar to an image icon, but it's like you're loading an image into RAM instead of loading an image to put on a panel. And then this is underlined because we need to surround it with try and catch. This can fail if it cannot find the file, right? And then on top of that, another reason it can fail is if it's not a supported image type. Like, let's say there's something wrong with the image file that maybe your browser doesn't care about, but Java cares about it. So if Java can't load like the metadata or something of it, then this is going to fail and you're going to print a stack trace, right? Then let's look at this. Local variable icon may not have been initialized. That's because this can fail, right? So if this never becomes anything, I'm just going to say it's null just to keep that consistent. And then we will say if icon is not equal to null, then we'll try to draw it. So basically, this is all saying if we were able to load the image, then we will draw the image. Hi, Otai. Is Java a good choice for game development? For indie games, I would say Java is a fantastic choice. It already has a graphics framework with things like JFrame and JPanel. There's even Canvas if you want to go back to the AWT libraries. But it has quick image loading, it has easy audio loading, and it can perform at high frame rates. I've written games that have run at like thousands of frames per second. And then you just have the update clock for the actual tick rate of the game to be like 60 times per second or something like that. Like, I honestly feel like Java is a lot stronger than a lot of people give it credit for. And it can even be comparable to like a C# or a C++ game, given certain circumstances. And this is all me also talking about using the Swing framework. If you choose to import something, like if you wanted to program for OpenGL or DirectX or something, then there's almost no reason to pick something other than Java, because Java will do all of the processing at the rate it's supposed to. It will almost never fail, same as like C# or C++. And then all of the graphics will be handled by your graphics card using like OpenGL or DirectX or something. So I highly, highly, highly recommend learning Java and getting into all the nitty gritty, how to load images, how to load audio, all that stuff. For things like, let's say C++, right? C++ doesn't have its own like graphics framework. You would either have to write it from scratch, or you'd have to access like Win32, or what is it on? You could use like X11 on like Linux or Mac. But you like that didn't come with the installation of the language, and you don't know that your client is going to have that framework in order to run the graphics of your game. But Java, if they have Java installed, then they already have the Swing framework. So if you write your game with the Swing framework, all they need installed is Java. And I kind of explained this, I believe yesterday, but pretty much every game is going to have one dependency for the language that the game was written in. So C#, you're going to need the C# installation. C++, the language itself is probably already on your system. For like Linux, Mac, or Windows, you probably already have a version of C++, but the problem is you need a graphics framework. So something like SDL2, and if you need to install SDL2 or something in order for your game to work, then your game still has dependencies, right? So pretty much no matter which language you choose to write your game in, it's going to have a dependency. And if your dependency is Java, like most people have Java these days. Like anyone who has played Minecraft has Java, right? So I feel if your only dependency is Java for your language, for your graphics, for like loading resources, all that stuff, if your only dependency is Java, then you don't have to worry about like bundling a whole lot of stuff when you distribute your game. So like I kind of feel like I went on a bit of a rant, but like yes, I think Java is a very good choice for game development. If you are not going to do Java, I would recommend probably going for like a web alternative if browsers can support the kind of game you're trying to make as far as like framework and like connection speed and all that stuff. If you do not want to use Java and web based is not going to work for you, then I would say like I really have a sweet spot for C++, but I could also see C sharp. The problem that I have with C sharp versus Java, even though they're very similar languages, is that C sharp has been going through this wave of we're trying to be cross compatible across operating systems, and they like kind of drop the ball every time they do it because they were mainly on Windows, and then they said, "Okay, we're gonna like do Mac and Linux as well." So they made .NET Core so that you could do like graphics on, or I guess not graphics, just C sharp on like Linux and Mac, and then they like half-assed it basically. Like a lot of things weren't working properly between all of the different operating systems, and then they were like, okay, we're gonna introduce a new graphics framework called like Maui or something like that, and you can kind of look into that. But I think they essentially with Maui, they said, okay, Maui's gonna be a Windows and Mac thing. And like we're gonna basically just ignore Linux. And like maybe for most users that's fine, but like my main operating system is Arch. So uh it's kind of frustrating when you are trying to write something but it doesn't work on all operating systems. Thank you, Java, but for web development, and you've never tried writing games. You're now deciding between Java and C sharp, so you can try writing a small game just for fun. If you're writing a small game, I would definitely go for Java. I would look up the like you can either go to my Cube Wars Java stream that I did I think that was yesterday. Or you can go to my YouTube channel. I believe I've uploaded it there as well. But I would watch that. And before that, though, you might want to watch the HTML version of Cube Wars that I did first, because the Java version I made was kind of porting the HTML JavaScript version to Java. And so I kind of rushed a little bit. I tried to explain what I was doing, but I'm doing a lot of cutting and pasting because the code does the same thing. And then I'm just kind of fixing it so that it does the language conversion from JavaScript to Java. So I would really recommend watching the HTML one first, and I'll explain more the logic that's going on while I'm writing that. And then when you finish that one, go and watch the Java one, because I will refer back and forth between the HTML one and the Java one to show you where I'm putting certain bits in the Java code. And that will show you how to make like a game loop that runs 60 times per second. It'll show you how to draw things to the screen. And then if you combine that one with this stream, then you will have knowledge of how to draw images and play audio for your game as well. So between images, audio, having a window, setting a frame rate, all that stuff, you can very, very easily make a constantly refreshing game in Java. But compared to other languages, you would have to take like several more steps, maybe import some libraries for graphics and things. So yeah, I'd highly recommend using Java. But I would check out the HTML JavaScript version I did first and see if maybe that would be better for your small game. Because if it is truly small, then I don't see why it wouldn't run in a browser, you know? And usually that'd be easier to code, easier to distribute because you just put it on a web server. So yeah, just kind of giving you some options. I'd just check out some of my previous streams, maybe the YouTube channel, and see what interests you, you know? I personally, I don't know a whole lot about C Sharp because, as I said, I've had issues making it like cross compatible and stuff. I believe they have a way that you can do graphics in C Sharp, so you don't need to import an external library. But I, for one, don't know how to do it, and I don't think it's cross compatible between operating systems. So that's why I would not recommend C Sharp. But most games today are written probably in C Sharp because Windows is the main audience. But if it's not written in C Sharp, it's written in C++. And those games can oftentimes run on any operating system as well because they'll utilize a framework like SDL2. So I'm sorry if this is a lot of words. I want to get a little bit technical so you can look things up if you're interested. But yeah, just in general, I would recommend doing like HTML, JavaScript, maybe put some PHP in. We haven't done a stream on that yet, but I plan on soon. And then if that is not good enough, then I would try Java because that'll definitely do what you need. Awesome, man. I'm glad you're here. um, let's see. Let's see if we can get back to what we were doing. Okay, so we loaded this file and then we drew it to the screen, right? Yeah, that's what we did. So now we've drawn the image at this size because we chose the size here, and then it's at this location as well. You're welcome, man. Anytime. Anytime you need help with anything, you can just come in chat and ask me. I stream Monday to Friday, but unfortunately, this coming Monday, I will not be streaming. I have a business meeting I have to go to. So basically, Tuesday, Wednesday, Thursday, or Friday, I should be streaming. And even if I'm like playing a game or something, still feel free to ask me about programming stuff, and I'll try and help you while I play. But I've been on a programming thing lately, so here we are. And you might notice like the mouth here is a bit mangled when we've drawn it to this canvas. It's because we haven't resized the image. We are just scaling it very roughly down to the size it is. So that's why it's all like pixelated. But we could do the same trick we did before to resize this icon before drawing it, and then it would be scaled a lot better. Now, again, we are loading an image from outside of our jar here. And I don't really prefer doing that. I like loading resources from inside of the jar. So let's look at how we might do that. Let's make a new file in core, and we'll call it like res loader or something like that, because this is going to load images from inside of our jar. And we'll just make a public static load image function. How about that? Now we're going to take a string that's going to be the name of the image. So image name. And this is going to return a buffered image because we want to load it into memory, right? So let's import that. This is mad because we haven't returned anything yet. We're just going to say return null for now, so it's not angry. And then we need to get the image into the jar to begin with, right? So let's right click on source. We're going to say new, and we're going to say source folder. Now inside here, we're going to say res as the folder name, very similar to what we did for the HTML JavaScript stuff. We're just making a res folder. And because it's a source folder, this folder is going to be included in the jar when we export it. So let's go get our image, I think off the desktop, right? We're just going to drag this into the res folder, and we're going to copy the file there. So if we open this, now we have Funa-chan here. Isn't she cute and very large? So now we have the image actually in our jar, and we could make more folders, I believe, inside of this. Let's even give this a test. We'll say image like this, and then we'll put Funa inside of this image folder. So this should be included in our jar because it's a source folder. And then anything inside of this should also be included. So we're going to make another folder, and we're going to put the image inside that folder just to show you can kind of sort your resources as well. We're also going to make a new folder, and we'll call this audio. How about that? So you can have multiple folders. You can sort them out however you desire. Now we need to load the image from inside of our jar into memory so that we can then draw the loaded image to a canvas. That's kind of the path we're taking here. So we're going to need a buffered image, and we're going to call this like loaded or something like that. It's the image we've loaded. And then we want to get something from inside the jar, right? Well, what's something that is already inside of our jar that we could say in relation to this, I want to find an image? Well, we know that our class files are going to be inside of our jar, right? So what if I just wrote the name of this loader, and I said res loader dot, and then I'm going to say I want the class itself, not like something inside the class. I want this class specifically. And then I say dot, and I can look at different things that this will do for me. So what if I say get resource as stream sounds interesting, or get resource, one of these two. Let's try as stream. And then we're going to put image name as the parameter here. And this is underlined because it wants this to be an input stream instead. Let me do a quick Google just to make sure that I am thinking of this correctly. Load image in jar. Okay, I am correct about this. An alternative to writing resloader.class is you can say like this dot get class if this is an instance that you're trying to load it with. But because we're making basically a static function, we're just going to use the class itself. And then we need this to be a loading. It says we can use get resource or get resource as stream. It works regardless whether it is in a jar or local file system. I don't think that's accurate, but we'll work on this. So ensure your image files are in a folder that your build system includes in the jar. Yeah. And when using loading methods, path must be relative to the class root. Which is one thing, is we're gonna put a slash here, and then we're gonna add the image name, because slash is going to be the very top level location of our jar file. So we want the top location of our jar file, and then we want whatever image we're looking for. And I'm even going to tack image onto this as well. And then a slash. Because we want to go to the root of our jar. And then we also need to go into the res folder. So we're going to go into res. We're going to go into image. And then we're going to get funachan.png, right? And let's try just doing decisions. Okay. Yeah, we're going to do it as a stream. And in order to do that, we need to say this is an input stream. And then we basically have a path to the bytes of this image file now. So in order to actually get those bytes into an image, what we're going to do is we're going to say buffered image. We're going to call this like stream or something instead. And then this can be loaded image, basically. This is going to be image.io.read, and we're going to read that stream. So we're going to use, surround it with try and catch, of course, because it can fail loading the image, right? So we're going to try to use this image.io library to read the bytes of this input stream that points to the image we're trying to load. And if it does load it, then it'll be this buffered image that we have here. And let's take this out here so we can have it in a larger scope. And we will do this. And then we will say if loaded is null, or if it's not null, how about that? Then we're going to return loaded. So when we try to load this image, we're going to get the bytes of the image. we're going to make this image be loaded from the bytes using image.io. And then if it successfully loaded that image, then we'll return that image from this function. If we did not succeed, we're going to return null. And that should work if I have written this correctly. So let's go back to our panel. And instead of icon equals all this stuff, because we're loading it from a file outside our jar, let's try and load it from inside our jar. So we want a buffered image, because we know that we can draw a buffered image to our canvas or our panel, right? And then we're going to say loaded, I guess, or maybe we'll call it Funa to make it a little more customized. And we're going to say resLoader, the class that we made, dot load image, because that's the function we're using to load the image, right? And then in here, we need the string. And the string was going to be the name of the image we're loading, which should be funa.png. So funa.png. And again, normally we would have to say /res/image/funa, but because we've already added that on here, we do not need this prefix here. We just need the image name. Now, we do need to check if Funa is null, because as we've written, it's possible it didn't load, and if it didn't load, then this function's returning null. So we still need to check if the image is null before we try drawing it. Most of the time, though, it's going to load properly, so we don't really need to worry about that. As long as we get it to work once, it will work every time. So if you're like worried about your file not loading all the time, if you ever do get it to load in Java, then it's a Java compatible resource. So let's just try this. We got some errors. So let's look at this. In event queue, input equal null, image.io.read. So we were unable to read the image into Java. One possibility, I guess that's probably not the possibility. I was going to say the image might be too big, but we did load it as an image icon. So I don't think it's too big. I think the problem might be in the location of this image. So how about we copy this? Let's try pasting it into the top level. And we will do /+Funa and try again. See, now it worked, which is very interesting. So when it was in a lower level folder, it did not load it like this. So the question is, how are we going to get it into a lower level? And I think I just realized the problem. Let's make a folder again. And we're going to call it image again. And we'll move Funa in there. I believe we don't need this res folder. I think this res folder basically gets dissolved, and the first folder in our hierarchy is going to be this image folder. So let's try image/that, and let's run that. And it worked. So I was correct. So when you're writing your path here, do not include res, only include the folders that it's in and then the image. But yeah, you can see the way that we've written the image loader here and the way we've loaded the image we wanted and then drawn it to the screen is working, right? So if you bundle this together, with maybe resizing the image first. Though I really recommend making your image resolution whatever resolution it's going to be in the game, like where you're drawing it. Because scaling images in Java can be kind of intensive. And if you're loading a really large image just to display it as a small image, then you're wasting valuable space in RAM that could be used to load other things, right? So try to keep your resolutions close to, if not exactly the same, as what you're going to draw it on your panel or canvas. But I'm just using this image as an example for this tutorial, so I'm not really customizing it myself to like make it perfect or anything. But yeah, so that's how you would load images into memory in Java if you're not going to use like a JPanel, or not a JPanel, a JLabel or something. Now, I believe I want to look up this draw image Java. We're going to see if it has cropping capabilities. We load an image. It's more flexible, scale, crop, transformed. It looks like it does allow cropping, and it's actually written the same way as in JavaScript. You just have this null observer on the end. So let's try to mimic kind of what we did in JavaScript. We're going to break these onto new lines. And let's look at this. So we said, I'm going to have to look up the proportions again. Image, pictures. We're looking at the properties of this one. So we saw this dimensions are 2103 by 4234 is the resolution of our Funa image, right? So we want, let's try the top third again, because that seemed to work pretty decently. Let's do 0, 0, because we're not cutting into the image at all from the top left, like, perspective. Like origin, whatever you want to call it. And then for the width, we wanted the full width. So 4, 2, 3, 4. And for the height, we wanted, oh, I wrote this wrong, 2103, because that's the width. And then we wanted a third of the height. Let's maybe do like a fourth-ish of the height, because this is almost 4,000. So if we divide it by 4, it's almost 1,000, right? And then this appears to be upset. And the type graphics is not applicable to the arguments, because our image needs to be the first argument, if you remember that from the JavaScript thing. And now it's satisfied. So we're going to draw the top fourth of the image, and we will draw it at this height and stuff. So it will probably stretch it, but it should be the top fourth. And it's gone. Fantastic. Let us consult Google Sensei. Source, destination 1, destination 2, source 1, source 2, Oh, backwards in Java? Is that why I'm confused? Let's cut this, move it down here, try it again. It is backwards in Java. That's why I was writing it wrong in JavaScript. So to make this look better, for one, we don't want 300, we want like 50 or something like that, right? Because we're not trying to stretch it, we're just trying to get a top fourth. Let's maybe try like 75. Okay, that's about right. So there is a pretty big difference if you're trying to crop it in Java. And it's that this is where you're drawing it on the screen, and this is how you're cropping it. Whereas in JavaScript, this is where you're cropping it, and this is where you're drawing it to the screen. But other than that, as you can see, it works the same way. So if you wanted to load, using your res loader, a sprite sheet, then yes, you can still use a sprite sheet, and you can still crop into the sprite sheet in order to get the specific sprite you're looking for. And then if you want to like skip through your sprite sheet and all that stuff, you still use the same math that I explained for the JavaScript stuff, which was this. We used this math, right? So if you want to know how to skip through your sprites sheet, go to that part of the VOD or YouTube video or whatever you're looking at, because I will explain it there. But yeah, that is images in Java. Now, there's only one way that I know how to play audio in Java. And I don't think we need like pretty much any of the stuff that we've made in order to do it. We will keep the res loader because we're still going to need to load the file some way. So let's get rid of this main panel, and we can delete this file altogether. And then we have our res loader, our mainframe. I think we can do it from here. So let's look up load audio from file Java. So an issue that I think we might run into, yes, I am correct. Our audio files that we made are unfortunately saved in MP3 format. Java does not support MP3s. So if you have an MP3 file, you're going to have to convert that MP3 file to like a WAV file, a WAV. And if we were making our own audio like we did earlier with our like Gregorian chant and our pews, we saved it as an MP3, unfortunately, and then we didn't save the actual project files that I said I wasn't gonna need. Well, I kind of need them, and they don't exist anymore. But we'll just make a new file. Pew! Pew! Okay. So now we have little pews. And let's try out the export option we were talking about, the trim blank before. For format, we need to choose WAV, which I believe, yeah, WAV. And we're going to call this pew, and we will save that. So now I have this pew file. We're going to try it in Pop Player. It does play, so we are good. Again, I'm going to not save the project, which hopefully won't bite me in the ass later. And then in res, we're going to make our folder for audio. We're going to say audio. And we are going to drag this pew.wave into that audio folder. So now this pew.wave should be inside of our jar because it's inside of our res folder, right? So what are we going to do with that? Well, we made an image loader inside of res loader. Let's make an audio loader. So we're going to return, let me look at this. Audio in Java. Play with audio. It's been a while since I've done this, which is why I need to look this up. Okay. It says using clip. We don't want clip. It all seems a lot more complicated than what I remember. Okay. Let's try this. Hopefully this doesn't rely on a different library. Should be complete. I'm sure there's nice ways. There's something called clip, which I think we're gonna try that and see if that works. So we're gonna load a sound, right? And this will be a sound name. This is going to be inside of audio instead of image. And this was sound name. And that will still be a stream that we're loading. We're not loading an image. We're trying to load a clip, apparently. Okay, that does appear to be pure Java. So we're going to try to do this. Let's cut this out. And we're going to say we're not returning a buffered image. We're going to return a clip. And we need to actually load the clip. So we're going to say loaded. Hey, Jilly, how's it going? Loaded is audio system dot get clip. And then this is going to be in a try catch because it can fail to load the audio and get a clip right. We're going to say clip.open audio system, which is a library I'm not very familiar with, but it will probably do what we're looking for. Get audio input stream. And this is going to be our stream. And it's not clip, it's loaded. Right? Clip loaded. Loaded is a new audio system get clip. Clip.open. Okay. So we're making a new clip. And then with that clip, we're opening a stream. So this kind of seems like, what is it trying to, we didn't have the correct exception here. We're just going to blanket statement, say exception. If there's any problems, then we'll give up. And then in order to play it, we're going to say clip.start. So we need to say if loaded is not equal to null, but we also want to know that this didn't fail, which I guess it would catch if it failed. Just for safety, let's make a Boolean called success. And we're gonna say false. So I want to make sure that it finishes this line no matter what. So if I say success equals true, then we know it successfully did this without hitting an exception, right? So then I will say if loaded is not null and success, then we want to return loaded. Else we're going to return null, right? You're chilling. I'm basically trying to teach how to do audio and images between like JavaScript and Java. It's something I was kind of avoiding with some of the games I was making, because it is a lot faster to not make those. So here I'm kind of padding my game tutorials by showing you some other things you can add to your games. So this should make a new audio clip, and if it loads properly, return that audio clip so we can play it. And I'll just fix some imports with Control-Shift-O. And then here, let's say clip, what do we call it? Pew equals, and we're gonna say res loader dot load sound, and then we need the sound of the audio clip, which is pew dot wave, and we need to import clip. And now that we have that, let's just say pew dot start is how you play the audio clip. I'm gonna pause the music just to make sure it does play. And it did in fact play. You guys can't hear it because I don't have the audio matched up like that, which I can try to do. Let's make a temporary audio source. And this is this. And we're gonna match the title or the executable. Okay. Let's open it and we'll see if this works for you guys. It in fact did not, which is depressing. But let's try to fix it. Let's try this one, because I want you guys to hear it. Pew! Oh, I think you heard the second part of it. Pew! Okay, it looks like there's a little bit of delay. You might not be hearing the first bit, but you do hear the second bit. But I'm hearing the whole thing, so it does work. And I need you to just kind of trust me on that, I guess. So let's remove the temporary one. You guys aren't going to be able to hear it anymore. And then, I mean, we played in audio, so that's cool. That was kind of the goal there. Let's look at looping a clip. I'm pretty sure at this point we could probably just say pew dot, and then we can look at different things. There's drain, flush, get controls, is running, is open. Maybe that's what we should be checking to see if it succeeded, is if it's open. Because we tried to open it with our stream, right? So if it is open, maybe that would be good. And then here's loop. We start looping from the current position. Playback will continue to the loop's endpoint, then loop back to the loop's start point count times, and finally continue playback to the end of the clip. If the current position with this method is invoked is greater than the loop endpoint, playback simply continues to the end of the clip without looping. Count value of 0 indicates that any current looping should cease, and playback should continue to the end of the clip. Behavior is undefined when this method is invoked with any other loop operation. Playback stopped during looping. The current loop status is cleared. The behavior of the sequence. Okay. So we are going to use this loop function probably. Loop continuously int. I think that's what we're looking for. So we're going to say dot loop, and we're going to say q dot loop continuously. Let's try that. And this should be probably clip dot loop continuously. Sorry, clip dot loop continuously, because we want the actual static value in here. So we're going to say loop, we're going to start it, and we're going to play. And it does indeed loop at the end of the audio clip, and it loops forever because we said loop continuously. So that's how you loop audio. And then you can probably do some similar audio management to what we did in JavaScript, where, like, let's say in this res loader, we loaded and we opened this specific stream. But if we had other streams, we could probably change what this clip is opening, and it would play a different audio file, right? So if we wanted to structure this a bit different, maybe have clip be like a more global thing, and then this was just loading a different, or like opening a different stream instead of returning a clip altogether, then we'd be able to just change what audio this clip was playing, and we could make something like a background music audio playlist or something like we did in JavaScript. So that is very cool. This is all pure Java. We didn't need to import anything. The only restriction that we had is we needed to use a WAV file instead of an MP3 file, because waves are uncompressed, which means that you can easily read them. You can read the data that's inside of them. But an MP3 file, I believe, has some compression to it. So Java doesn't have any way to read it since it's compressed. So yeah, if you just make all of your audio files WAV files, most image formats are supported by Java. So you'll have like JPEG, PNG, bitmap, like all of those are supported by Java. If you want transparency, I recommend PNG. I haven't really tried any of the other transparent formats, but I know PNG works. I'm trying to think of other things I've run into. As I said, occasionally you'll try to load like a PNG or a WAV file or something, and it'll fail to load. Oftentimes, it's because you don't have the location correct in your get resources stream. And so you have to play around with it like I did during this stream to figure out that you don't write res. But eventually you'll probably get it working if you get this this location right. And then the other thing was, if there's some sort of error in the file, like if you have a bugged PNG file, like it's not fully downloaded, but you tried to load it or a bugged wave file somehow, and it just does not load, you will get your stack trace, and it will probably tell you that for images, it'll say this image IO failed in your stack trace. For audio, it'll probably say that this get audio input stream failed. So you'll have to kind of look at your stack trace to see kind of what's up with your program, right? And if you see one of these two showing up in there, then it could be that your file's bad, but it will be like this will be the main problem. If it says like getting the clip is the main problem or something, then you probably have like the location wrong, or the like get resources stream, you probably have the location wrong. But yeah, we covered audio and images in both of those game formats and showed you several different ways that you can do that. Trying to think if there's something else we wanted to cover. I guess I can play music again now because we're not messing around with audio. um, I don't know, guys. I feel like I covered it all. There's a couple things I can show you with canvases and things. Maybe I'll show you that in JavaScript. It's a bit more involved in Java. So maybe I'll do it for a game sometime to show you in Java. But I'll show you something cool you can do in JavaScript and HTML that makes managing images a lot better. Do think I'm gonna go to the bathroom quick though, so I'll be back. Okay. I am back. So yeah, I think we were wrapping up Java, and we were gonna go back and play around with some things in HTML. So let's I'm not gonna keep this pew file. Let's go back to our htdocs file. And we were doing this in Z. I don't think I actually need this open. Maybe I do. Let's open this in Chrome. Okay. So I never saved this, is why this is still drawing. Okay. All right, let's increase this for you guys. Okay. So, some things I want to show you with images still. I'll probably have to add to the end of the title that we're gonna do more things at the end, because I'm kind of jumping back and forth at this point. Let's do an image. So we'll say let Funa equal new image, right? And we said Funa onload is a function. And then we said Funa's source is res image slash Funa PNG. Put a semicolon there before I forget. So when she loads, we were going to draw her to the screen, right? And we drew her to I need to add my references back. That's annoying. Let canvas equal document get element by ID. Canvas let can equal canvas dot get context 2D. Okay, now we can draw to the canvas. So then we said when we load Funa, we want to draw image Funa at like 0, and then we resized her to like 150, 300, I believe. Let's try that. Okay, we're back to basically where we were when we were drawing Funa. So I want to show you some cool canvas things we can do, right? So what if I made another canvas below the one that we have? We're gonna make this one 150 by 300 though. And that gives us this little canvas here because we already have some CSS. So you might notice these are the same as what we did here, right? So let's get a reference. What do we want to call this? I don't really want to call it canvas 2, but we might end up doing that. Let's call it Fucan, because we're going to draw Funa in it. Or maybe Funa can. It's like a tuna can. That's kind of funny. And then we're going to need references here too for Funa can. And we're going to call it fcan. How about that? And Funa can is the element we're getting. We're getting the context of that one too. Okay, so instead of drawing it to can, let's draw it to fcan, right? And we're going to draw it in the top left corner at 150,300. Let's do that. It did not do it because we didn't change this to FunaCAN. So now we do it, and she's down here now, right? She's on our new canvas. So what you can do is you can actually draw this canvas on this canvas, because a canvas is actually seen kind of like an image, like a PNG or something. So after we've drawn Funa to this image, what if I say the first canvas we have, draw image, and we're going to draw FunaCAN at 0, 0. What's that going to do? It already has a resized version of Funa-chan from the first time that we drew her and we resized her, right? I didn't have to resize her again. I'm doing the full width and height because we're doing the full width and height of this canvas that already has her on it, right? So if you, for whatever reason, just cannot resize the source image that you're using, what you can do is you can say, instead of having this canvas on the screen, you could say let new canvas equal document dot create element, and this is going to be canvas, right? And then you could say let new can is new canvas get context 2D, and we're gonna need to set some things, right? So new canvas dot width is 150, and new canvas dot height was 300, right? So instead of drawing her to this canvas, let's draw her to one that is not on the page. Can we do that? We're going to say new can dot draw image Funa. And we're going to refresh, and we don't see anything. Let's open the console though and refresh. We also don't see any errors, which means it's probably doing what we told it to do, right? So we have this canvas that's loaded into memory, but isn't on the page, right? We didn't have to add it to the page in order to draw on it, which is really interesting. But what if we tried to draw this new canvas onto this big canvas? Now when we refresh, oh my gosh, we still got the resized Funa-chan, didn't we? Because essentially we've made this canvas just in memory, right? And then we did the same thing. We drew a resized version of her on it, and then we drew the one that's in memory onto our visual canvas that we already had, right? So this is a really cool way that you can also load images into memory and then draw the image. But why might you want to do the canvas instead of saying something like new image and loading it this way, right? Let me show you something kind of cool. And we're going to go back to the visual one so you can kind of see what's going on. But let's say what do we want to do here? This is fcan, and we should be drawing FunaCAN. And so we're back to where we can see this one, right? So what if we, for instance, made this 300, sorry, not this bit. We want to make the canvas 300 instead. Okay? We're going to refresh and we see that she's moved a bit. Let's change where she's drawn to be let's see, 300 divided by 2 or something. We might need to divide it by like 4. I don't know. We might have to play with it. Let's try like 150. That would be off the screen. Let's try 75, see where that puts her. Okay, that's about half, right? And you'll notice when we changed this one, it also changed this one because it includes the full size of this canvas, not just the content of it. So act as though this canvas as a whole is an image, and we're drawing that whole image here, which is not what I was trying to show you, but is something to keep in mind, right? So you can do interesting things with the canvas called transitions and translations and stuff. And the end stuff is the technical term of it. So we can do a rotate on this canvas. But before we do the rotate, let's do a translate. And I'm going to show you kind of what that's like. So we're going to say fcan. We're going to be doing the translations on this canvas. We're going to say translate. And then this is going to take an X and Y. Pretty much, we're changing where 0, 0 is on this canvas to be somewhere else. So what if we translate it to be 75, 75? And then we draw the image. Well, let's look at that. Okay, so if 75, 75, I probably did some math wrong. It's 300. Yeah, these should be 150. Sorry. I'm trying to do half and half of the width and height. So now you see if we started here and then drew Funa-chan, then it's in the right location, right? So what if we wanted to fix Funa-chan so she's back in the middle? Well, we'd have to adjust these numbers to be consistent with our new translated origin, right? And that is what that's called, is the origin of where you're drawing it from. So if we're drawing Funa, we want to draw her at negative, like half of what her size is, and then like half of what this size is. So I think I'm doing math wrong again. Let me think for a second. We'll just throw some numbers out and see what happens. Okay, I did the math right. So now we look like we did before, but the origin of where we drew it is in the center. And we used negative numbers to compensate to put it back to where it was, right? But we can do interesting things with this canvas now that the origin is in the center. Like, what if we say fcan.rotate? And I think that this takes radians. So we're gonna say math.pi times 2 would be 360 degrees. That's just some basic trig for you. And then we want to divide that. Well, hold on. No, we want math pi divided by 180. That would give us 1 degree. And then we can multiply that by how many degrees we want to rotate this canvas. So I'll say 90 and save. Now what do you think is going to happen? Because we're going to go to here with our origin. We're going to rotate 90 degrees, and then we're going to draw Funa. She's sideways now. Isn't that cool? And we can change this to be like 45. And now she's diagonal. But what you'll notice is she's not just diagonal here. She's also diagonal here, right? Because we're drawing this off the screen, right? So what if we have one image that's like your character top down or something, and we want the image to point at our mouse as we go around, because it's like a mouse-driven game or something, right? Then you can have an on-mouse move, so you can get the location of the mouse, and then you know the location of your player is going to be the center of the screen. And then you can do some basic trig to figure out what the angle is that your player should be rotated to face your mouse. And I'm not going to get into that right now. If you know trig, then you should already know how to do that. It's a pretty basic trig. But I will show you how to do that when we make a game that is top-down like that. We'll probably make like a shooter or something like that, where you run around an open world and you shoot like zombies or something. I think that'd be a pretty good game for us to work on. But the thing with that is, now you can rotate your sprite by that many degrees, and you don't have to rotate your entire canvas that you're using as your main canvas anymore. Because what you'll get with this stuff is, let's say I want to put a square right here now, after I've done all this rotation and everything. Well, if I say fcan.fillRect, and I say I want it at 0, 0, with 50 width, 50 height, right? And I'm going to change the style so it's not black. Fill style equals blue. Now when I go to draw this, it put my square here. That's not where I wanted it. I wanted it up here, right? Well, I could either move where I'm drawing the square to be before I'm doing all this translating and rotating, and then I can do that, and that will be placed correctly. Then it will do the translate, rotate, and draw Funa-chan crooked, right? Or I could draw it after, and I could just say, you know what, I want to rotate this back -45, and then I want to translate it back -150 and -150. Okay, that'll probably work. That still puts it in the corner. But now we're like doing things and then undoing the things we did, and that's really frustrating, right? So if you were doing this on your main canvas, you'd be rotating, translating, rotating, translating, rotating, translating over and over and over again. And these are pretty expensive processes to do on a canvas. So why don't you just have an in-memory canvas that people can't see, that you're just doing these rotations on a really small canvas just meant for your player, and then you're just drawing that canvas in its entirety in the middle of your main canvas that you haven't done any rotations or translations on. So that's why I wanted to show you this. It's very, very useful for very specific games. But it's something not a lot of people know about, and it would save them a lot of time and headache. There is one other thing that you can do to go back to the way that the canvas is by default instead of rotating it back and translating it back. And I believe it's called restore. Let's just try that. And it did not work. I think because we have to make a restore point to return to. So let's Google this thing. Restore. Yes. Okay. I am correct. So if before you do these translates and rotates, you say, well, I want to save the current translation and rotation of the canvas. We haven't done anything to it, so it should still be 0, 0 as the origin and 0 as the rotation, right? So we're saving that state that the canvas is in. And then we're going to do all this translation, rotation, we're going to draw it or whatever, and then we're going to restore. This should reset all of our settings for translation and rotation back to what they were when we last saved it, which would be the beginning when we first made the canvas, right? And just because I don't want it making any issues, I'm going to put this save outside of our onload, because if this was ever called again while we were rotated and translated, then it might save it at a wrong place, and then we might not be able to restore back to what we were before, right? So let's try this. All right, our square is back in the corner, which means that we've restored back to where we were originally before the translate and rotate in order to draw this square regularly. And this is something else that you can do to reset your stuff back to how they were, but you don't want to, for instance, be like, I'm going to rotate and translate to draw something, and then I'll restore, and then I'll rotate and translate to draw something else, and then I'll restore, and then I'll rotate and translate to draw. Don't do that, okay? Make it a lot easier on yourself. Just make a lot of these little canvases in memory. And I recommend doing it on the page before you do it in memory, because you'll run into issues if you do it blind. Just saying. Because for instance, let's say we make this back to 150, right? What's going to happen is we're actually cutting off some of our image now. And that's cutting it off here because we didn't have room to actually draw the whole image here anymore. And so it's not part of the canvas. And because it's not part of the canvas, it's also not going to be drawn here. And that's why I made this bigger, is to give it room for that rotation. So then the full image would be drawn. But yeah, don't do like rotate, restore, rotate, restore, rotate, restore, because as I would guess, restoring and saving and all that stuff can be intensive as well. So if you don't need to rotate something on a canvas, please don't. It will probably take a lot of your processing power. Just rotate an image in like an image editor, load that as a separate image, and then switch from your previous image to your new image. But if you need like smooth rotations, kind of like how this is, let's I kind of want to play with this a bit. Let's say set interval render at 1000 divided by 60. And then let's make a function called render. And here we're gonna do our translate and drawing and stuff. So we're gonna save the current thing. We're gonna translate, rotate, draw, Funa. And then let's make a rotation equal to 0. And then instead of 45 degrees, let's say rotation. And then after we render, let's say rotation plus plus. How about that? So if I did this hastily correctly, we're going to draw Funa-chan regularly. Let's get rid of this square. We're going to draw her regularly. And then every time we render, we're going to have the degrees increased, and we're going to draw her at 1 degree turned. And we're actually going to need an fcan clear rect here, or we're going to start getting some overlap. Let's say Funa can offset width, and Funa can offset height. I believe that should make this work. So now when we refresh, it doesn't work, which is fantastic. Oh boy. It's really doing something, isn't it? Okay. That's kind of scary. I knew I was doing this fast, but I didn't think I messed it up that bad. So we're loading our image. When it's loaded, we're making a loop for every 60th of a second. We're going to clear a rect. Increasing the rotation of the rotate. Let's just type rotation. Oh, I understand. Because when rotation is greater than 360, we need to reset. So rotation equals 0. Let's try that. That still is having issues. I think it has to do with us restoring. Oh. It's because we're drawing her multiple times. No. That wasn't the problem. It appears. Why are we drawing her on fcan twice? I guess because I didn't refresh here, but we need to clear the rectangle. Let's try doing a restore here. Let's try doing a save here. It might be like a context thing. There we go. That's what we were looking for. Okay. So we're rotating Funa-chan 1 degree every 60th of a second. And then you can see up here, we're also doing it, right? But we're not actually clearing this canvas, which we do need to do if we want it to not overwrite like this, even though this itself is kind of cool, I'm not gonna lie. We're going to clear the main canvas, and this would be canvas and canvas. Okay. Now she's rotating here, she's rotating here, but we didn't have to do any translate or rotation on this canvas. We're just drawing it regularly, and it is adapting to whatever this canvas is doing, right? So this is kind of what I was trying to explain. And then we could also center her, kind of like the shooting game or whatever that I was talking about. So let's just say canvas offset width divided by 2 minus 150, because this is 300 by 300, right? So we want half of that. I could even just write 300 divided by 2. And then canvas dot offset height divided by 2 minus 300 divided by 2. Let's run this. Okay, now she's spinning in the circle. Very, very similar to what I was talking about, right? And then we can just make a toggle that's like, if I'm pushing right button, then we'll increase the degrees of this canvas. If I'm pushing the left button, then we'll decrease the rotation, and we'll have another check to see if it's less than 0, then it will be 360. You know, we can do all that sort of stuff. So I can use keys to rotate it, or I can have it point towards the mouse using some trig functions. But yes, this is what I was trying to show you, is the power of rotating and translating a canvas can be very, 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 very good, and save you a lot of time programming. And also give you smooth animations. Because if you were making a new image for every degree that this could spin, do you know how many images you're loading? The answer is 360. And I don't think you want to manually make 360 images for your character, or manually program their location into your game. So yeah, this will save you a lot of time if you want to rotate a sprite in your game. And then you can just do collisions and things as you would normally. Just say, like, if it's within 300 width or 300 height, then you'll take a collision. Or you can get really specific and you can do advanced collisions that account for rotation and stuff, but I wouldn't do that. That's too much work, frankly. But yeah, so now you know how to put a canvas on a canvas. And as I said, you could do this all off screen too. You don't have to have this second canvas here. To be really quick with it, you could just make this display none. And then for whatever reason, we're not clearing this rect anymore, which is interesting. It's very interesting. Does clear rect only work when it's visible? I doubt that. So maybe don't do this. Anyway, I'm trying to show you different things you can play around with. And like, this is one way that works. If you were doing it in memory, I'm pretty confident it would work that way. If not, then you can find some different way to clear the area. We could, for example, fill the area with white, or if you don't want the white showing up here, what you could do is you could make a new canvas, draw the image on this canvas, and then, like, this is your new canvas, okay? So you make this new canvas, you draw your character 0 degree rotation, right? Then you draw this canvas on this canvas, and then you can completely just forget about this canvas and make a new canvas and draw your image at 1 degree, and then draw that new canvas on here. And that'd be another way that you can, like, basically clear your canvas, is you're just making more and more canvases. You're making new, like, images, if you will, every time you go to draw it, which will be more intensive, but it would work. So that's just some considerations to take in. What other cool stuff can I show you? I don't want to stray too far from today's goal, which was images and audio. And as I said, you can do this rotation stuff in Java. It's just a lot more complicated. So I would look it up if you're interested, but I'm probably not going to do it until I actually need to. I guess I could show you like on this main canvas. There's a couple other things that you can draw on canvases, like you can do like a line. So if we did draw, I think it's just line. I think you do your starting point. So let's say 0, 0. It might actually be draw stroke. And then you're going to choose an ending point. So we'll say like 100, 100. Let's try that. Nope, it's wrong. Okay. Draw line canvas.js. Oh, it's a bit different. Okay. So what we can do is we can say the canvas begin path. And then at the end of it, we're going to say can.stroke. And then between begin and stroke, we can move or line to. So we're going to can.move to, and this is going to be really similar to translating. We're not going to see anything. So we're going to move to 0, 0, which it should already be there, but we should probably move it anyway. And then from 0, 0, we're going to line to 100, 100. Now, if we look, we have a line here that goes from 0, 0 to 100, 100. And that's the line we just drew. But then you could also do like can.line to, and we'll do 200, 100. How about that? If we refresh, now we have a line that comes down here and then goes off to the side. So you can actually draw your own shapes using this pathing kind of technique. And I can kind of show you that. Let's move to 10, 10. And then we'll say we want to move to 100, 0, line to, we might need to do 110 here. It depends on how it works. I'm trying to make it not on the edge so you can actually see this whole object. We're going to say line to 100, 110. And then we're going to line to 10, 110. And then we'll go back to 10, 10. What shape do you think this is going to make? Hopefully not an error shape. That would be cool. It's a square. Because we started at 10, 10. We moved to 110. We moved to 100, 110. We moved to 10, 110. And then we moved back to 10, 10. So we made a square, right? And then we can also do like, if I wanted to go like this, and then I could just say, you know what, we're going to move back to the origin here. Oh, I not move to line 2. Now we've made a triangle. Because I went here, and then I went back to the beginning. So you can do really, really cool things. You can actually draw like 3D shapes doing this because you can make your own custom shapes, right? Like I made a cube by drawing each square, like each face of the cube in 3D space, and then did like a projection calculation, like a projection function to project it to a 2D canvas. And I made like a rotating cube before. That was really cool. But the difficulty is filling this path. I want to see if that is actually easy. Fill path, JavaScript canvas. You begin the path, you move your line 2. Instead of stroke, it says we can use fill. And let's say fill style is red. Boom. Now you can draw shapes and you can fill the inside of the shape with a color. Now that is absolutely dope. Like, I cannot lie, that's really cool. I'm unsure if you can do the same thing in Java. I know you can do lines, and you can connect lines to make shapes. I need to figure out if you could do that fill, because if you can, then I can do some pretty interesting things. Let's look up begin path fill Java and see what comes up. So we have graphics 2D object. We're gonna move to line 2 close path. You can do it in Java too. That's dope as shit. That's really exciting. And it's basically the same thing in Java too. Is you need to make a path object, which I guess is a path 2D dot double path is new path 2D dot double. So you make one of these, and then from there you can just say like path dot it's either move to or line to, similar to what we're doing here. So it's very, very, very similar to JavaScript. And then you would just do the graphics object, set color to change the fill style. And then you would do a make the graphics object, you make your path. You do need to close the path. So instead of just fill, you would need to do the path closed path. And then it would be g.fill path is how you would fill the object. But that's awesome. Definitely look that up if you're interested. I was unaware you could do that in Java. So, who knows? I might get back into 3D again, because I can do some really interesting stuff in 3D with that. But not today. We're gonna go back to non-Java. We're just doing JavaScript. So again, we drew this triangle, we set it to red. We can make it green if we want. Same thing, right? And images completely ignore your fill style, by the way. They don't care. They're only gonna draw what the image has. You can draw circles. That's something I can show you. Draw circle JavaScript. You draw an arc. Oh, it's also a path. So instead of line 2, what we can do is we can start a path. We can move to... I want to actually just move this. I'm going to delete it. We can move to... And is this going to be the center of this thing? Center X, center Y, radius, start angle. Okay, so it looks like you move to the center of your circle. If I went to 50-50, because we're going to make a 100 by 100 circle, then we said dot arc. So we're going to make like an arcing line instead of just a line. We're going to say the center X and center Y. But we never moved. Maybe this is the top left of the circle. And then we'll go 50-50 for the center. The radius is going to be 50 as well, because we said we were making a 100 by 100 circle. The start angle is going to be 0, and the end angle is going to be 360, which I believe is radians. So we need to say math.pi divided by 180 times 360 will get us fully around the circle. And let's do a stroke, not a stork, a stroke. Huh. Why do we have this line here? Is this origin of the circle here? That'd be kind of weird, right? Let's say 150. Wow, that's strange. So I guess because we're starting here... Oh, that actually makes a lot of sense. Because our grids are flipped in graphics, right? So X positive is here, Y negative is here. And then we kind of like, we rotate the grid 90 degrees too. So like we start here and then we go, okay. Anyway, I'm trying to show you things that you can do. And I'm sure you can do fill here too, and it'll fill the circle. So it's going to take some math, it's going to take some thinking, but you can do all of these things, right? You can draw circles, you can draw random polygons that you want to draw, you can draw images, you can fill them, apparently, which is awesome. You can also just do the strokes, or the, yeah, the strokes, right? So you can also adjust things like line width. So if I made this a stroke again, a stroke, that's what I'm having, is a stroke. then you see this is kind of a thin line, right? It's like a 1 pixel thick line. Well, I can also, alongside setting the fill style, I can set the line width. And if I said this was like 5, then when I draw it now, it's going to make that line width thicker. So if you need it thicker for some reason, then you can do that. I also want to know, can I stroke and fill? Oh, that's awesome. So I could even fill and then stroke. And now we're going to get like a border effect around that color. And if you want to change the stroke color, change stroke color, JavaScript. Sorry, I'm Googling all this stuff. I'm trying to include this all in like one stream or video. Yeah, so instead of fill style, it would be stroke style. And then we could say this is like purple. And that changes our line to purple. And then our fill is green, right? So anytime that you're doing things with a stroke, you're going to change the color with stroke style. Anytime you're filling, you're going to change the fill with fill style. Gosh, man, like, I'm like digging through my brain, trying to think if there's something else cool I can show you about the graphics stuff in both Java and JavaScript. But if you can do the path stuff in Java, I'm sure you can do like stroke or fill and change those styles as well. It seems like these two forms, like between Swing and the HTML5 canvas, it seems like they really tried to have all of the same functionality, which is really, really nice because I love both of the languages. And to have them similar means that I don't have to remember as much. Yeah. That's really all I can think about right now. I can't think of anything else that you would need to make a game. You can make images, you can rotate your images, you can draw any shape you want and fill it or do a stroke around it. You know, use PNGs for your graphics for games if you want them to have transparency. So like if I wanted something behind Funachan, I'd have to make sure that Funachan is a transparent PNG in order to do that. Another thing you can kind of think about is if you wanted to do like a filter. Let's go here and do this on the temporary canvas. I'm gonna say fcan fill rect. I'm gonna fill the entire thing, right? But I'm gonna set the fill style. Fcan fill style. I'm gonna set it equal to RGBA. And I'm gonna say I want like a red filter on it. So I'm gonna say 25500, and then I'm gonna add a transparency of 0.2. Now we have this like pink on top of our image. It's not actually on top though, because it's before our image that we draw this. So let's go after our image, and we will do this filter right here. So now it's on top of our image. Ooh, We need it after this, but before we add it to the main canvas. Just some graphics ordering priority we're doing here. Now you can see the entire image is like more red, right? And it's kind of annoying that that's going to give us a background like this. And there are probably ways that you can just add the filter to the image. But I can't think of any right now. I'm honestly getting kind of tired. We've been straight streaming a bunch of different programming stuff for about 4.5 hours. But yeah, so I wouldn't really recommend doing this sort of filtering. But let's say you had some like special effects you wanted to add on top of this that you wanted to show in here too. You could do that as well. You don't have to draw this image and then add the special effects. Especially if you want the special effects to rotate with Funa-chan, then doing it down here would make more sense, right? So that's something you can kind of think about. And a reason you want to do color filters, just to give you an example of this, is let's say we want a blue filter on this. Now, if everything had this blue filter on it, it would kind of look like it was nighttime. And you could very gradually change this filter's RGBA value to become something that's more like yellow, like a very light yellow, and that would be daytime, right? So then you don't actually have to make like all these different time period sprites for your images. You just have to add a filter on them. So whatever time it is in the game changes what filter is being applied, and it'll slowly change the filter from like a blue to like a yellow, and then back to a blue depending on the time, right? And then you could have this cool day-night cycle in your game that you didn't have to manually add to all of your sprites. So that's really cool as well. I definitely encourage adding that to games. Day-night cycle adds a lot of like ambient effect to your images. It really gets the player involved, makes them feel like time is actually advancing instead of just having like a clock in the corner that tells them what time it is, and they go like, "Oh, I forgot, it's nighttime. I can't do this thing or whatever." Right? So it's like, well, everything is blue, which means that I can't do such and such. Or like maybe fishing is better at night. So when everything starts turning blue, then I want to go fishing, right? So yeah. With that, honestly, I think I'm gonna tap out. I've been spitting out a lot of knowledge. And between this stream for images and audio and the two Cube Wars streams and the one Quest for a New Kingdom stream, like between those, I think that's 4 streams. Doing math. You can make all kinds of games. Like all kinds of games. There's not a lot more difficult stuff that you're going to have to get into to make like your own thing, you know? So I really recommend just watching these streams and jumping on it and start making whatever. And if you run into a problem, I'll be here next week, man. So just come and chat, ask me your questions. But yeah, I am gonna tap out now that I've just been talking straight for 4.5 hours. If you appreciate the tutorials I'm doing and the like game development stuff I'm working on, please do leave a follow. I'm trying to get the associate on both Twitch and Kick. And if you're on the YouTube, maybe consider subscribing. I may occasionally play video games, but I'm honestly not really feeling like it for stream right now. So we'll probably be doing a lot of programming in the future. But yeah. Once again, not streaming this coming Monday. I have a business meeting that will take place during my usual streaming hours. So blame the business I'm meeting with. I feel like there's something I always forget here. I guess I can randomly tack on the HTML entities that I covered earlier, the ones that are like and quote, like these things, those are just HTML things. You don't need UTF-8 in order to use them. It's just an HTML property that they've defined for HTML. So I think I mentioned something about them being related or something. They're completely unrelated. But other than that, I think we're good. So thank everyone for coming. Thanks Otai for the questions. Thanks Chili for showing up. Thanks Semph for always being there. Yeah, I'll wrap it up. I hope that my tutorials are helping people make the things that they dream to make, because that's kind of why I'm doing this. And I will see you next, like this coming Tuesday is the plan. If not, check the Twitter. Like if you don't see me during my usual streaming hours, check the Twitter. Make sure I'm not, sick or something. I don't want to waste your time. And if you follow, you will be notified when I go live. So I really do recommend just following, and then you'll know when I'm up and spitting out programming knowledge. So yeah, I will see you all another time next week probably. Bye. Have a good morning, good afternoon, good night, wherever you are, and I will see you next stream. Bye.